Here in section 3 of chapter 2, we're going to be looking at polynomials and division, looking at the factor theorem and the remainder theorem. And we're going to use division to get to those ideas, both long division and synthetic division. So we just want to refresh our memory here on the idea of long division with polynomials. So this statement is telling us that if we have some function p of x and we have the ax minus c as a factor, then we can rewrite that as the factor times the quotient. Factor times quotient there. That's just like saying, okay, if I have the number 63, I know that 7 is a factor of that, so I know that I can write 63 as 7 times some other number, the quotient of that. And of course, that would be 9 in this case. So we're going to use long division here. And so we just want to run through the long division with this example to refresh our memory on that. We're taking the 6x cubed plus 17x minus 104x plus 60 divided by 2x minus 5. On this, we want to remember that if we're missing any powers of x in our polynomial here, that we want to fill that in with a 0 x to the appropriate power so that we're not missing any places there. Okay, so long division with polynomials really easier than long division with numbers. Because we have the 2x here, we know we need to multiply that to get a 6x cubed, so we're going to have to multiply by 3x squared. I like to write mine above the other x squared term. Some people would write that above the 6x cubed. Doesn't matter. And we're going to take that and distribute it through our dividend. Sorry, divisor there. So that's going to give us the 6x cubed minus 15x squared. Now, if the 6x cubed is not the same, then we've done something wrong. So we would go back and fix that. We want to subtract here. So we'll go through it a little more formally this first time. Subtracting means we're really adding the opposite. And so we have 32x squared, and the 6x cubes drop out. So bring down the minus 104x plus 60. And we go on to our next step. So we see that to get 32x squared, we're going to have to multiply by 16x. So I put a plus 16x here. Distribute again. It's going to give me 32x squared, as it should. Always check and make sure that really is what it needs to be. Don't just assume. And then 16 times 5 is going to be minus 80x. Add the opposite. So that's going to give us the 0x squared that we needed, and a negative 24x, and bring down the plus 60. Okay, scrolling down here to give us a little more room. We now have a negative 24x, so we're going to have to multiply by negative 12. Is going to give us negative 24x plus 60, so that when we subtract, we are going to get a 0 there. So our answer is 3x squared plus 16x minus 12 for the quotient. But the question was, factor it completely. So we now know that this original polynomial can be written as 2x minus 5 times 3x squared plus 16x minus 12. So take a moment to pause the video and finish factoring this, and then come back for the answer. And so we see that factoring the remaining trinomial then gives us the 2x minus 5 times the quantity 3x minus 2 times the quantity x plus 6. And we have factored that original expression completely. Again, pause the video here and try this one on your own. And the answer is B. Okay, moving on. In our first example, we did not have any remainder, so now we're going to do a long division that will have a remainder, and we can deal with that remainder in one of two ways. So here it's showing that we have the quotient f of x over d of x equals q of x plus the remainder over the divisor. And here they've just written f of x is the divisor, times the quotient plus the remainder. So two interpretations of the same thing. And which way you want it depends on what you're doing with that particular problem. So work out the long division on this, and make sure you get the same thing that I come up with on mine. So pause the video now and work this out. And so we see that works out to be 3x squared minus x plus 4 with a remainder of 10. So there's one interpretation of our answer. But sometimes we want to rewrite that and think of it instead as 3x squared minus x plus 4 plus 10 over 2x minus 1. 2x minus 1, of course, being our original divisor.